All right, so this problem's asking us to find the derivative of this function implicitly. And then once we have that, we're going to use that to find the equation of the tangent line passing through that point on our function. So let's start off with the implicit derivative. We're going to need that to be able to write our equation of a tangent line, because it's going to get us our slope, right? Because that's the big idea, is dy dx is our slope of our tangent line. So let's start off with that derivative. We're going to start off with y to the fourth. The derivative of that is just a regular power rule. 4 comes out to the front, making it 4y cubed. Now chain rule kicks in. We say we did the derivative of the 4, but we haven't done the derivative of y. What's the derivative of y? dy dx. Now you can write y prime, but I personally will make mistakes if I do that. So I always write dy dx. Now we're going to move right along. We're going to say, okay, now here, this is fun. Here we have a little bit of a product rule. I'm going to look at this as negative 6x times y. Okay, so my first factor being negative 6x, the derivative of that would be negative 6, leave the y alone. Plus, but since we have a negative built in with our negative 6, I'm going to say it's negative minus, leave the 6x alone. What's the derivative of y? Well, that would be dy dx. Now we're going to move right along. I realized I skipped over this on the last one. I'll hit it now. Is what's the derivative of x? Well, it would be dx dx, just like the derivative of y is dy dx. This is dx dx. But dx divided by dx, well, that makes 1. Right, so that's why the derivative of x is 1. Derivative of 20 is 0. Derivative of 0 is 0. All right, now comes the fun part. We're going to go ahead and sort. We're going to get every term that has dy dx in it on one side, and we're going to get every term that has no dy dx's in it to the other side. And so to me, it's easiest, leave the dy dx's alone. I'm going to leave them here. So we're going to leave that as 4y cubed dy dx minus 6x dy dx equals. And now I'm going to add the terms I highlighted in blue. We're going to move them to the right. So I'm going to add 6y, and I'm going to subtract 1. Okay, now the whole goal here is to get dy dx by itself, and now that they're all by themselves on one side, I can factor them out. So we're going to go ahead and factor out dy dx, which would leave us with 4y cubed minus 6x. That's what's going to be left after we factor out dy dx. Now, of course, do not forget your equal sign. Cannot just come and go and disappear. Last but not least, we need to finish solving for dy dx by dividing by, I always call it the blob. Whatever is multiplying it, I do not care how ugly it is, it's just going to divide. So we're going to divide by 4y cubed minus 6x. And now we are ready to look at our derivative. Dy dx equals 6y minus 1 over 4y cubed minus 6x. Now, we have done this derivative implicitly, which is nice, but the issue is we have x's and y's left in our answer. And that's okay as long as we know both an x and a y value, which it gave us. It told us negative 20 comma 0. So for me to find this derivative, this slope of tangent line at negative 20 comma 0, that just means everywhere I have an x, I'm going to replace that with negative 20, and everywhere I have a y, I'm going to replace that with 0. So I'm going to go ahead and sub those in. So that's going to be dy dx equals 6 times 0 minus 1 over 4 times 0 cubed minus 6 times negative 20, right? And finally, we're just going to do a little simplification. 6 times 0 is 0. 4 times 0 cubed is still 0. So that's going to leave us with dy dx equals negative 1 over negative times a negative makes a positive. 6 times 20 would be 120. So we now know the slope of our tangent line. So the slope is negative 1 over 120. So now, how do we write the equation of a tangent line? Well, how do you write the equation of any line? It's y minus y1 equals slope times x minus x1, right? Point slope form is always my recommendation. Now, we're going to go ahead and say, what do we need? I need a point and I need a slope. Well, that this line is going to pass through. Well, the good news, we just found the slope of it, and they gave us the point of negative 20 comma 0. So we're just going to sub on our values. So it's y minus the y value of my point equals the slope, which we just found was negative 1 over 120, times x minus the x value of our point, which was a negative 20. So a negative and negative make a positive, resulting in y equals negative 1 over 120 times x plus 20. Now, if the problem simply states find the equation of the tangent line, you're done. If it says find the equation of the tangent line in slope-intercept form, okay, so then all we need to do at this point is solve for y, which we already did. So now we're just going to go ahead and distribute our negative 1 over 120, which would give us, negative 1 over 120x plus, well, it would be minus since we're distributing through a minus, so minus 20 over 120, which would simplify to be negative 1 over 120 x minus, let's see, would be the same thing as 2 over 12, so that'd be 1 over 6. And there we go. So we have found the equation of the tangent line at the point negative 20, 0, and we have found the equation of the derivative using implicit differentiation.